So this is another one of those substitution problems. If we say that x is equal to 5 secant theta, we seek expressions for sine of theta and cosine theta in terms of x. So we can either use identities or we can go back to the triangle. I'm going to prefer to go back to the triangle again. I just seem to like the triangle. So I want to create a triangle where there's one angle called theta. Oh, but you notice in the expression we're given, the trig function is not isolated. So I'm going to divide both sides by 5 first, just so I know what I'm dealing with here. Looks like secant of theta is x over 5. And we could work with that. Or remember that secant is a reciprocal function, which means it might be easier to look at it in terms of the cosine. And that means cosine of theta is 5 over x. Oh, would you look at that? We already have one of the answers. Sweet. Okay, so cosine of x is 5 over x, which means the adjacent is 5 and the hypotenuse is x. Well, that's interesting. In order to find sine of theta, though, I need to find the third side of the triangle. Pythagorean theorem is here to save the day one more time. So I have 5 squared plus I have no idea squared equals x squared. And that means question mark squared is x squared minus 25. And I think we see it right now. The unknown side is the square root of x squared minus 25. So I'm just going to erase that and put the square root in its place. And that means that sine of theta is root x squared minus 25 over x. And like I said before, this is going to be useful once you get to calculus. I'll save the surprise for you until then because I really can't justify it for you right now. But it is nice to know that we can transform between the two worlds. So have at that, and thank you so much for watching. And as always, watch out for more videos. Thanks so much.